Never get tired of that music. Hey everyone, welcome to another Friday edition of the Laser Review, our weekly live streams here on YouTube, on LinkedIn, Facebook, Twitter. We're everywhere. How's everyone doing?
Pretty great.
Sorry, I should introduce you guys. So we got Mike and Don here in our Mississauga office. Hey Mike, say hello.
Hello.
Okay, awesome. Don, how are you feeling?
My head here. That's my halo.
That's okay. It's like the Messiah of lasers.
Exactly. Yes.
That's what his business card says.
The Messiah of lasers.
Exactly.
Well, say hello in the chat. Let us know where you're from. We'll post your questions to Mike. I mean, the idea behind this is to have basically like a walkthrough of the 360. It's probably our mid-range, the most mid-range flatbed Speedy that we have. And while I talk, I can show you guys this awesome promo video. So the 360 flatbed, we're basically going to do a basic walkthrough for people that have never seen lasers before, kind of show you a little bit of the design, the print, and then do a couple of jobs on the laser live as well. For the more advanced people that have already seen this, definitely ask Mike. He's the end-all knowledge of everything, everything laser related. We always take a shot when he says, I've been in this business for 30, what is it, 29 or 30 years?
35
Almost
years.
30 years.
30 years.
Almost.
And Mel always does that chiseling thing.
Yeah, exactly.
So he's not here to do that.
Exactly.
Well, welcome, Mike. If you want to take it away, maybe tell us a little bit about, your experience with the 360, what type of customers you have that buy this particular machine, what they use it for, and then maybe we can go into the walkthrough.
Yeah, it's relatively similar size to, say, the Speedy 300 in terms of the overall size. The 360 came out after the 300. It was sort of a machine that they wanted to sort of bring in that was sort of between the 300 and the 400. So they brought the 360 in. In terms of its motion system, it's like the 300, but in terms of the bed design, it's sort of like the 400 in terms of its downdraft table and everything. Its plenum that's on the physical machine itself. So it basically does the 140 inches a second, the same as the 300. We have a lot of mid-sized users that like it. Sometimes people can't, maybe they don't have the size or the budget to go to the 400. So the 300 is a good machine for cutting, also a great machine for engraving. It's certainly one of the more popular machines that we sell because it does have lots of abilities to do engraving very fast, do rotary engraving very fast, and also to do cutting. Even if you're looking to cut 3/8 or like 9 millimeter, 12 millimeter, the machine is very, very good for cutting that too. So
perfect. And we have actually our first, lead, the United Nations Council of Indigenous People. Welcome, looking to acquisition a couple of machines for our international intergovernmental organization. So if you're looking for some information, if you're in Canada, email us at youtube@troteclaser.ca. We'll post that on as well. If you're not from Canada, go to troteclaser.com to the contact page and find a local either Trotek subsidiary or a distributor in your local country. So I guess with that, Mike, we can maybe get started on the walkthrough. So I'm just going to share your screen here. If you want to go to your Coreldraw. So why don't you take us through it? When you usually show people that have never seen lasers before, what do you kind of go through?
Well, this is sort of an example sometimes that we'll certainly use when we're talking to people about the laser machine. And the thing that I always sort of tell people is think of the laser engraver exactly like you would a laser printer. And it basically works the same way. Whatever's black is going to be your etching color, and typically whatever's white's not. So the same as a laser printer. If you're going to print out to a laser printer, whatever's black is going to print, whatever's white doesn't. In the case of this logo here, you'll notice that we have a red outline here because what will happen is the machine will do the etching, and then or the engraving, and then basically it'll go and cut the piece out after. Okay, so that's typically, you know, how we sort of take a look at it. You know, when I'm sort of talking to people who have never sort of used the experience using a laser machine before. So.
Somebody asked if we always demo logos from losing teams.
Yes, exactly. Yes, we always do. Yes.
We're still proud of them.
Still proud of them.
No matter who says what.
One year they'll win.
Actually,
I will have to say though, just on that note, I was 7 years old when they won the last cup. So,
wow.
So I was alive when they did win. So
was that the 19th century or what? No,
it was the 18th. That's what we use bones for skate blades.
There we go.
Exactly.
So actually, the same person that doesn't like the Leafs is asking, what kind of air compressor do you use for your air assist?
Well, on the 360, the standard setup is the air assist pump is actually built into the machine. So, and the beauty of the air assist pump being built into the machine is good for two reasons. One, it's very quiet. And the second is we can have the machine control the pump to turn on when we need it. So sometimes in some of other systems, if you're raster engraving, the air assist pump is still on. It's sort of running in the background, creating a lot of noise. When it's plugged into the machine, when the machine powers the pump, when we tell it to print, or to turn on, which we do here, I can turn it off for the black color, and I can turn it on strictly just whenever the red color appears. So,
sorry, Mike, I'm just going to show my screen here for a second. Can you explain what the air assist is for people that don't know what the air assist is?
Yeah, so basically what we're using the air assist for two reasons. Typically, one is it's flushing the optics to a certain degree, which sort of cuts down on some of the dust contamination that will happen on the lens as the machine is working. And two, it's there to blow any flame out so that we hopefully will get a cleaner edge. And on certain materials, we want the flame to be blown out so that we don't create a fire. So basically the air assist is doing a couple things for us. Okay, on this particular 360, the pump is built into the machine. You can get an external gas kit too if you want. So again, if you're looking to pump in your own air, which most people don't in this case on this particular machine, you can do that. So, but most of the applications really are strictly just using the internal pump that's built into the machine.
And somebody's also asking, do you have the pump in the 300 as well?
Yes, all the machines when we sell, we include the air assist pump. Typically, the problem in the old days when we didn't have the pump in there, some people wouldn't buy a pump, and therefore it sort of caused their cutting not to be as good as it should be. Plus, they also had some other issues. So the nice thing about having the pump, or us including the pump, is that everybody has the pump. And it teaches everybody to use the pump because it's very important that you have the pump installed on the machine and you're using it when you need to use it. So if you had an external air pump there, for a lot of people it created problems. It might break down, and it was running all the time. It's very noisy. So when it's built into the machine like this, it just comes on, and a lot of people just take it for granted that it's there, which is what we want them to do. And it forces them to use the pump.
And I'll just quickly show, so this is the air compressor here inside the machine.
Yes, exactly, yeah.
Somebody was asking, how Hounds TV, sorry, he is a Leafs fan, so there you go. We do have a Leafs fan here. Is Coreldraw the only go-to software to use with the Trotec Speedy?
Well, we actually we have two options now with the laser system. We have the standard job control software, which we've had for almost 20 years. Very robust program, best sort of program I've ever used to go along with the laser. Gives me a lot of functionality. And if you get job control cut, which gives you curve correction and object ordering, very, very great, good software. That software allows us to print directly from any output software. So, you know, whether it's Illustrator, whether it's Corel, whether it's AutoCAD, whether it's Microsoft Word, Excel, the job control software basically is just a print driver that allows us to take that information that's being printed from the output program, the design program, and then takes that into the job control software, and then allows us to then send it to the laser machine. Okay, and we can do that two ways. We can have it print directly from Corel, and it goes over to the laser machine and just starts engraving, or you can come into job control as I've done here, and you can see the output file here, and that allows me now to move this around wherever I want on the bed. Okay.
Just from my experience, I mean, Coreldraw is definitely easier than Illustrator. I mean, we can use any design software. I mean, you could use Microsoft Paint if you wanted to, but because it's a print driver. But most people use Illustrator or Corel. I mean, if you're a beginner and you don't know too much into the design world, Corel is probably easier to learn. I mean, I think maybe there's more functionality in Illustrator, but you know,
not necessarily. I think the thing to remember for a lot of people that are new to the laser machines is that you have to have a program that's vector based. So basically, it outputs the vector designs. So, you know, a lot of people might say to me, "Well, I know how to use Photoshop." Well, Photoshop is good for doing photographs, but it doesn't give you output for cutting. So again, you'll need to use the Illustrator to be able to do the cutting. Coreldraw has the ability to do cuts and engraving in the software. So again, it's a good program. Programs like Microsoft Word, we have people that, you know, use that for tag layouts and everything. Great program, but doesn't give us any vector output, which then allows us to not be able to do any cutting or anything like that with that program. So that's always important to remember, that Illustrator, Corel are the typical programs of choice for that reason, that they output vectors and they output the raster information, which is the engraving information.
And a lot of, I mean, schools, architects use CAD software like Autodesk and
AutoCAD
AutoCAD.
Yeah.
Just to chip in here from the camera also, as somebody who is a here, let me.
Yeah, we can hear you. We can hear you. Go ahead.
Hello.
Oh, there you go.
As somebody who is an Illustrator fan, I would say that Illustrator, if you're already familiar with the Adobe programs, or if you're already purchased into, say, the Creative Cloud because you have Photoshop already, or Acrobat already, or some of the other, don't be frightened by Illustrator. It is probably a little bit less. I agree with Mike. It is probably a little bit less user-friendly than Corel is. But if you're already familiar with Photoshop or some of the other Adobe programs,
it'll be easier to.
The learning curve is not nearly as steep, and at the end of the day, I mean, as these guys are saying, even Inkscape, right, which is a free program if you're looking to get started, you know, it can be a great place while you're sort of still learning your way around Corel or Illustrator or whatever your choice might be.
Yeah, and Hound was saying, thank you, answered my question. As long as it's vector-based and print driver, I can adapt. Yep. All great question, guys. So keep them coming. Mike, we got a bunch here. I don't know if you know the specific one. How much PSI does the air assist provide? Is the compressor continuous duty?
Yes, it's continuous duty, and I believe, so it doesn't have a reservoir in there where it's actually, you know, the tank will fill up and then it stops. It'll just basically work as you need it. I think it's 30 psi. I could be wrong on that, but I think that's what it is. Stevens on the other side of the wall there could ask him, but I believe that's what it is. And again, you actually have 2 nose cones with the laser.
Don, can we switch cameras?
Yeah, if you come to this one here. So we have 2 nose cones on the. We have two nose cones here. The wider one is when you're doing acrylic, and the narrower one is for doing all other materials. And typically, this is sort of like basically the air comes in and then vortexes around and then speeds up and then comes through the nozzle. And then it's pinpointed at the actual cutting curve. When you're cutting acrylic, you don't want that accelerated air going in because you tend to get run lines in your acrylic. This tends to just flush, sort of fill the area with air. Still gives you a little bit of air push, but you're relying more on the downdraft to be able to draw any smoke or debris away that way. And it still gives you enough air to blow any flame out, but not enough air or not too much air where you start to get runs in the on your cuts of the acrylic. So is that all right? You see
Yeah.
that?
I hope that answers it. Also, great question here from Tyler PWM. I've followed the acrylic tutorials, but having a hard time with 3/4 inch to 1 inch acrylic. Gut feeling, how much should I defocus? What kind of laser do you have, Tyler? Mike, I don't know if, I mean, even on the 360, if you're cutting a 3.5, 1 inch acrylic, I mean, you need 120 watt, right?
Well, the rule of thumb from a production standpoint is 10 watts every millimeter. So if you're cutting, you know, somebody wanted to cut 1/2 inch acrylic on a regular basis, then their minimum laser wattage should be 120 watts. Now, that being said, you know, I had somebody last week that cut 3/4 with a 60 watt, and they went really, really slow. And they, you know, they had a 2-inch lens, which again is you know, those are, I told them, I said, you better stand there and watch this thing because like you better be ready to lift the lid up really quick if you're going to have a problem, you know, if you have a problem. What he's asking for is focusing into the material. Most of the time we focus at the top of the material. So on the 360, you know, if you want to focus, do you have this? You just press the up and down keys here together, and you get a sonar focus here. And that focus is based on, you know, the distance of this lens to the material here, which in this case is a 2-inch lens. If you have something really thick, what happens is the beam starts to come down and start to come out like this in almost like a point. It gets wider and wider, and then the cutting ability becomes a lot less. So the idea is if you focus to the middle of the material, you might lose a little bit on the top and you might lose a little bit on the bottom, but it'll be more consistent 90-degree coming down, as opposed to nice at the top and then starting to get bad at the bottom. Now, I told the gentleman that was cutting the 3/4 inch, I said, you know what, this is certainly something that you can do once in a while, but I wouldn't be doing this on a regular basis. Even 3/4 inch and 1 inch on 120 watt is really, really hard on a tube. You know, that's really going slow and that's a lot of power. And you got to be really careful with the material that you're working with. So yeah, good question as to what his wattage is on his machine. You know, whether that's certainly something that I would even entertain. So.
And what's the wattage for the 360 here?
This one's an 80 watt. So I mean, if we were sort of looking at somebody came in and they said I'm cutting 6 millimeter 1/4 inch or I'm 3/8 maybe, you know, this is sort of a good machine for that type of material. You can do some 1/2 inch with it. And again, I wouldn't be using a 2-inch lens for the 1/2 inch. I'd be using a 2.5 inch lens. That gives me a little bit more depth of field, so that my the amount I'm in focus as I go through the material is a little bit more consistent. The kerf is a little bit wider. The beam size is a bit wider on 2.5 than 2 inch, but I get a little bit more consistent geometry in terms of 90 degrees when I'm going through my material. Okay, so that certainly would be something that I would sort of do. So if I went to 120 watt on a 360, now you can cut 1/2 inch, and theoretically, I mean, I've cut 3/4 inch MDF, but again, you start getting into 1 inch, and your beam geometries are really starting to go out the table. I mean, on our 200, 400 watts, we have 5 inch, 7 inch type lenses for that type of thickness, just so we get a nice 90 degree edge when we cut it out in terms of the profile. So. And
in terms of wattage that people should get, I don't know if you've mentioned already, but what do we say, like 1 mil per every 10 watt?
We say 10 watts for every millimeter for cutting. For cutting. Yeah. I mean, the other thing to remember on these machines is that they're production machines. So, and when I say production machines, the one thing that I sort of stress to people is these machines run at 140 inches a second, right? So they're very, very fast in terms of their speed. So you want a wattage in the machine so that you can travel at somewhat of a high speed, because the faster you go, the more product that you can push out the door, right? There's no sense buying something that's really fast that has a very small wattage, because you're never really ever able to achieve the speeds that the machine was made to do. So again, that's why we try to get people to come into the office to our showrooms to see the machines, because then they get a better appreciation for how fast the machines go. Because we get people that come into the office and they say, I have to cut 1/2 inch acrylic, or I have to do this product in X amount of seconds or minutes or whatever. So it's easier for them to see the machine working, and they can appreciate how the machine works based on the wattages are there. The thing to remember that I always tell people on the machines is, you look at the 300 or the 360 or the 400 in terms of engraving, the quality for the most, it's very hard to see any difference in quality. In terms of the engraving quality. There are reasons why the 360 and the 400 are better cutting machines, because of the downdraft tables and that than on the 300. But again, that also is dependent on the thickness of the material that you're cutting. Right.
Sorry, Mike, can you come closer to the webcam on your laptop just so people can see it?
Oh, sorry. Yeah.
No, it's good. We can still see it. So there's 2 questions here about CFM and exhaust. One's from Brian. What is the CFM needed for the exhaust of this machine? And also, I think we had the same question. How much CFM would you require for the exhaust? Yeah. So can you talk a little bit about that and the exhaust?
Yeah. So normally what I suggest, I'm just going to go into this is the suggested dust collector that I would normally suggest with the
So can you just give us just a very basic, for people that don't know anything about the laser world, why do you need exhaust? What does the exhaust do for the laser machine?
Yeah, so what the exhaust does, you're going to generate smoke, and you're going to generate dust, and what you're looking for is a system to be able to pull that dust and that smoke out of your machine, and if you're blowing the smoke and the dust outside, it's not like you're outside, you're going to see smoke going out. You're just really going to have a bit of a smell there, and therefore, and what you have to make sure when you buy a dust collector is you buy something that is strong enough so that you remove the smoke and the dust out of the machine quick enough so that it's not getting on the lens prematurely, and it's not contaminating you don't want dust in the machine, on the motion system and that, because that will over time cause issues with your machine. So it's always good to have a dust collector that's very, very, that's has a lot of power, and it can suck out the dust and the smoke very quickly.
And I'm just showing, Don, can you show us the exhaust that Mike is using, like the Quattro? So if you guys are in the States or in Europe, you're going to be using our Atmos exhausts, but sorry, I'm just close my screen. Yeah, for Canada, we use the Quattro exhaust system, and that's indoor. So we sell these as well. But what Mike's saying is, if you wanted to vent it outside, Mike, can you give us maybe differences or one versus the other, venting outside versus doing something in-house like this?
Yeah, I mean, typically, most people are gonna vent outside. It's typically it's the least costly, because really all you're doing is you're buying in this case here, a $300 dust collector with a bit of piping, and you're gonna blow it outside. Okay. For most people, that's typically what they want to do. That typically gives you good airflow. There's 600 CFM on that dust collector, 8 inches of static lift, which is a good level of static lift to be able to. That's what draws the dust out of the machine. So again, you've got good flow of air. You've got good dust removal. But there's two problems that you have when you use an external exhaust like this. One is you got to make sure that you're not beside a restaurant which has an outdoor patio, because again, if you're cutting acrylic, it's not going to smell very nice for the people in the restaurant or the patio. So again, that's always something to consider. What happens outside. If you're cutting wood all day, it's going to smell like a fireplace, and most people don't really care about that. But again, there are people that are cutting things that sometimes the smoke is a little bit nauseating. So again, you have to be careful with that. The other problem with an external exhaust is you're drawing air from your room and you're blowing it outside. So again, the problem with that is that if you have you're drawing the heated air or the air conditioned air out of your room and you're blowing it outside, and that air has to be brought back into the room, so that your furnace then is basically having to work a little bit harder, because now you've got air movement in your house. It's not normally too much of a problem, but again, it's always something to consider. I have some people that will keep their window open in their room a little bit, just to allow a little bit more free air to come into the room. If you take a look at the dust collector, it solves the issue of the air, because the air is drawn into the machine, goes through the dust collector, and then is pushed back into the room again. The other thing is that we don't have to worry about blowing smoke outside, because again, the smell is trapped inside the filters itself. So again, we're not pushing. We don't have to worry about that, about what happens outside. Everything is staying inside. The problem with the dust collector, again, is it's a larger cost to buy the physical filter, and it also, then you have that cost of changing the filters as you are working with the machine. On the particular Atmos filter here, there's 4 filters in there. There's a bag filter, there's a cloth filter. Bag filter looks like a filter, like a bag filter in a vacuum cleaner. Just remember that bag filter is not. It's not like where the dust goes in there and then over time it fills up and then you put it in the garbage or you dump it out. Basically, the dust sort of sticks to the walls of the bag, and then basically what you end up doing is having to throw the bags out. And what happens is then you're going to have the bag normally gets about 80% of the debris, the residue, and then it filters through the rest of the filters. So as the particles become smaller, they're trapped by the succession of filters that are next in line. So you've got a cloth filter which looks like a furnace filter, and that gets a certain amount of the dust, and then it goes into the HEPA filter, and then it goes into a charcoal particulate, which looks like little rabbit pellets that you would feed a rabbit, but they're charcoal instead of grass or whatever, right? Mm-hmm. So again, what ends up happening is that you, at the end of the day, you've got smoke that comes through that is 99.8% clean. And then therefore it's very safe to be using that. The drawback on a like I said on the Quattro is the cost of the filters, the cost of the unit, and the draw is not as good as it would be with you at a dust collector. So your CFM is less. Your static lift, I believe, is around the same, maybe a little bit more, but again, it's a bit of a trade-off. So if you're doing a lot of cutting and everything like that, certainly my preferred way of working is to use a dust collector. But if you can't, then certainly the Quattro is a good alternative to be able to use instead of the external exhaust.
Mm-hmm.
Okay.
Again, Quattro in Canada, Atmos pretty much everywhere else. Got a good question here from Raul. Just joined here. I did have a question about how durable are the markings made. So I think Raul's referring to if it fades away, like any of the engraving. I'm just showing like one of Mike's videos here for the photo engraving wood that he did. I mean, we certainly have different kind of Lamicoid sheets. One is made to withhold weather, like outdoor trolleys, things that are indoor trolleys. But I guess, Mike, if you can comment in general to the durability of the markings. I mean, you can obviously engrave deeper as opposed to lighter engraving. I think the first one here, this video is a little bit of a light engraving, but I don't know if you could talk a little bit about the durability of the markings or the engravings.
Well, it's all going to depend on the material you're working with. I mean, typically, most of the time, anything that we engrave is going to be durable. It will depend on where the product is going. A classic example that I use a lot of is where we sometimes have problems is with a Thermark material, which the problem with stainless steel is that you can't etch stainless steel with a CO2 laser. But we can make a mark on stainless steel if we use a Thermark. And what we do is we spray the Thermark on the steel, and then the CO2 laser, it's a glass frit. The CO2 laser causes heat, and then it turns into a glass, and then it bonds with the steel, and it's got a black pigment in there. So at the end of the engraving, you've got a nice black finish. Now, typically in most applications where there's not a lot of handling or abrasion or anything, that mark stands up quite nice. However, I've had people put them on the back of a watch, and the acid from the skin will wear it off. I had people that did tags like this, stuck them in an oil rig, went out to the ocean, and the salt water being very abrasive, actually took the mark away. So again, and that's why we normally have the fiber laser to be able to make a more permanent mark in the material.
And this is a fiber I'm showing right now. So the
Exactly.
first one was the CO2, what Mike was talking about with the spray, and this is direct marking with the fiber.
Yeah. The other problem with, if you look at a knife, for example, like a steak knife or something like that, you'll see a black mark in there, and that's normally an annealed mark. And that's done with a fiber laser. You can't use the Thermark on a knife typically because it's not FDA approved. Therefore, even though it is inert, there could be issues with that. So again, typically, when you're working with an eating utensil or something like that, the annealed finish, which is kind of like a black oxide finish, is nice because there's no depth engraving to trap the bacteria. It's just basically a surface mark. So again, that's the preferred. So there are some materials where we would have problems where the mark could come off. Lamicoids, again, another classic example of typically the Trolleys material we sell is fine for signage, for name badges and everything like that, but not fine if somebody's going to have an industrial abrasive cleaner that's going to go on top of the Lamicoid. We have Lamicoid specifically designed for that material. So again, sometimes you need to know, it's always good to ask the customer, if you're doing tags for people, where are these tags going to go? Because the last thing you don't want to have happen, which I've seen happen before, is to do product for people product, the machines or whatever get out. Like we had problems with anodized aluminum on transformers. You know, people put the anodized aluminum on the transformer went to Saudi Arabia 6 months to a year later. The sign's all gone, and now somebody has to physically put a new ID tag on that physical part. So again, the customer didn't, you know, understand or realize, you know, what would happen if that plate was out in the middle, out in sun for 18 hours a day in huge heat temperatures, or in the Amazon, same issue. So again, you know, we have special materials for those applications. So therefore, if in doubt, you know, talk to, you know, George, one of our material specialist people that are selling the materials, customer service, because they understand, you know, what works in certain situations and doesn't work in other situations.
Yeah, probably the most, I guess, one of the strongest metals that we sell is this stuff right here called the Durablack. There's Don right there.
Yeah.
But yeah, it's a more expensive metal, but it's there to withstand the elements. I mean, they put this for
it's military grade.
Okay.
So that specification is from the U.S. Army, the military, and when they're looking for, or the aerospace type people, you know, looking for something that's going to last for I think it's 25 years.
Wow.
And again, so it's expensive, but customers, you know, they have no choice. If they're going to do tagging for certain applications, then the tagging has to meet a certain spec, so you have to buy the appropriate product for it. And again, you know, that's why the Durablack was designed for those applications, because they used to use metal photo, and nobody wants to, or they would have used an acid etching type process. But again, you know, a lot of people, you know, they don't want it, those processes aren't easily as available as they used to be, so they had to come up with something different, which the Durablack is a product that was designed for that. So
yeah, and if you're in Canada, check out engraving-supplies.ca. That's where you can find all of our materials, acrylics, plastics, metals, wood, for the laser machine. I guess we're moving on. We got lots of great questions. Keep that up, guys. Jamie's asking, what is the promo price for a Speedy 360? So again, we can't give any pricing on this web stream. A lot of it depends, obviously, on power, different settings that you're getting with the laser machine. Even ballpark, we can't even disclose online, because a lot of people watching from around the world, prices do differ based on taxes, shipping, logistics, and so on. So if you're in Canada and you're interested in a demo pricing, we actually have a promotional running now on demo machines. Just send us an email, youtube@troteclaser.ca. And we can get you some demo pricing. The other question we had from Ed, do these lasers run on 120 or 240 power?
Yeah, that's a good question. So all the 80-watt laser sources that we sell in the smaller format, in the Speedy machines, they're all running at 110, 20 amp typically, because most people are buying 60 or 80 watt systems. And so that's 110, 20 amp. If it's a 120 watt laser source, then it's 220. And power supplies will take anywhere from about 208 to about 234, I believe. So 238, I think. So, you know, we're good for most for most people in Canada anyway. So, and in Europe or whatever, then, you know, typically it's going to be 220. But in Canada, it really depends on the laser source. So if you're running an 80 watt or less, then it's 110, 120, 20 amp. And then if you're running a 120 watt, then it's 220, 15 amp, if I remember correctly. So.
And okay, so the 120, that would plug directly into the wall then?
No, well, I mean, all machines are going to plug directly in the wall.
Right, I mean, without that special outlet, the 220.
Yeah, so 120 is for 80 watt systems or less.
Right.
Okay, 120 watt lasers you have to run 220 or
Perfect.
240. So.
And then we do certify our lasers in Canada, ESA and CSA. Well, we ESA them in Canada, so we have electrical certification on them as well.
And that is by law.
By law, yeah.
Yes.
So if you're getting a laser from overseas, make sure that you have the proper ESA certifications. If it's not a Trotek, I mean, because that could be an issue. It might not be legal to plug into your wall in Canada.
Yeah, the biggest problem with that is with ESA is that can cause two problems if you don't have that ESA. If you have a fire and the and your insurance company finds out, your SOL. The other issue, which is more important, is if you have employees and they're injured, then you could be legally liable for any injury. So not only are you going to have problems with the with somebody getting hurt, but you're also could face some legal issues. So again, very, very important to make sure that what you're buying and is ESA approved or CSA approved. Typically in the laser machines, very hard to get a CSA approval on that because there's health welfare has to get involved in it, as well as the other department. I remember Alan went through that. Not easy to get, but ESA, we have to have that. That's your bar that has to be done in Ontario and a number of other provinces in Canada. So,
from Rahim, what's the use case for printing from Excel? I mean, is that print merge, or what do you usually do with?
That would be print merge. So we have customers that due to their internal setups, it's easy for them to bring in a file in Excel. And again, in job control, it's quite easy because you can do a print merge. You can send 80 small plates over to job control, grab all 80 of those, and then drag them onto the job control bed, and they'll just sort of nest themselves out. And bingo, you're ready to go. And for a lot of people, especially if you've got pre-cut plates, works perfect. And so, there's times where printing from Excel is for certain people, more of an industrial application, where we're putting a machine into a company, that's a better scenario for them. The Excel has, a serialization in it, basic one. But the big issue is being able to take CSV files from databases and then getting that information easily into Excel, and then instead of going to a label printer is going to a laser. So
before we continue with there's plenty more questions. Mike, maybe we could show a quick demo, and as the laser's engraving and cutting, we can continue with the questions.
Sure. Yep. So if you've got a logo here, I'm going to just send over the logo in the page format. So I'm just going to go File Print, which is Control P on a Windows-based system here. Remember, we do this job control is only available for Windows, not for Mac. We do have the Ruby software that is in beta, is available for anybody to use. That's a web-based program, and that is available to be able to be working from Windows or from a Mac. So I'm just going to go into the preference menu of the print. So this is just a standard print window that comes up when you print, and then from that format, I have the ability to put in a number of parameters for the physical machine itself. And if I click on this little icon right here, this is the database for the system. So when the software is installed, it puts a bunch of presets in there for a lot of materials, and all the materials that we sell. Okay. And again, the way the laser works is black is going to be engraving, excuse me, and red is going to be cut. So again, I have the ability to engrave or cut.
And that's just standard practices, right, Mike? I mean, you can assign engrave or cut to any of the 16 colors in your design.
Exactly. I mean, it's just really something that we've done over the years. Normally, we want to distinguish the engraving from the cutting, just so that when we're in Corel, we can actually see Probably can't see that now because it's hidden. But when I look at a page, when I look at a job setup, I can see that black is engraving and I can see that red is cutting. So it just makes it easy. I mean, it could be red could be cutting and engraving, and black could be red could be engraving and black could be cutting.
Right.
As you say, it doesn't really matter. It's just that sort of kind of a industry rule. Not rule, but a suggestion that we tell people, and that's the way typically most people will set their jobs up. The engraving is based on power and speed for the most part, and the way the laser works is that most people want to go as fast as they can, so they run at 100 power or 100 speed, and the power then is related to the amount of speed. So the way I always sort of tell people, it's kind of like touching a stove. If you touch the element really quick, you don't burn yourself. If you leave your finger there for a long time, then you burn yourself. And the laser works the same way in terms of power and speed. If I'm going at 100% speed and I'm going at 100% power and I'm not happy with the depth of engraving, the only way I can achieve more depth of engraving is to slow the machine down. Okay. And when I start slowing the machine down, what do? I get more depth, but more importantly, I lose my productivity, which now this is why we look at higher wattages for machines. Because, if I'm running a 60 watt laser and I go to 120 watt, I get double the output on most products. It's not always true because it depends on the materials that you're engraving. But if I'm doing wood engraving, then 60 watt is going to be half the speed of 120 watt in most applications. And cutting is the same thing. If I have a 60 watt and versus 120 watt, the 120 watt is going to cut twice as fast on most materials. Again, if I'm cutting paper all day, well, that doesn't hold. But if I'm cutting 6mm acrylic or 6mm wood, the 120 watt is going to be twice as fast. Remember that this is a percentage, so this is 1%, and that's 1% of 140 inches a second. So it's still relatively fast, and again, that's material dependent. Once I have my power and speeds for my materials, then I can save them over here in the database, and anytime that I want to use one of these materials, it's quite easy for me just to select one of these, and it will populate the information, the data I need for that particular material. The air assist is on or off. I normally have it off for engraving. The Z offset allows the table to move. Again, we talked earlier about focusing more to the middle as opposed to the top. So this allows us to move the bed. And again, we have top down or bottom up engraving. I normally do top down most of the time. There are some custom features in here which we'll use for certain applications.
Sorry, Mike, to interrupt. Just a quick question to chime in. Inches per second, don't you mean millimeters? Someone's asking.
Well, it could be inches a second, it could be millimeters a second, depending on on whether you're imperial or metric.
Okay.
Okay. So I'm an old guy, so I typically still talk millimeters as much as I can, but
You're not that old.
No, I'm not that old. Sometimes I have to relate.
You didn't misspeak though. 140 inches a second is actually, it sounds high, but it is actually the correct number.
It is the correct, yes.
Yeah.
In the machine, and it's always important to remember that okay, Don, can you have this camera on the machine?
Yeah, we're got you on the machine.
Okay. So I'm going to pause. I'm just going to put the machine in suspend mode. Okay. So if the machine only goes this far, like this, it's never getting to 100% speed because it's got to start, stop, come back the other way. If the machine is going over here, now it's getting to 100%. So now it's doing the 140 inches a second. So it's always very important for us to always move left or right as far as we can go. Okay, the Speedy 360, 300, and the new 400 both all have 5G motors in them, so they're basically allow us not only to run at 140 inches a second, a little faster on the 400, but the big difference is the start-stop time. So is very, very quick. So I don't have a lot of overshoot. So I don't need to go really far to stop to stop the inertia of the head moving. It stops very quickly and it accelerates very quickly, but it still needs a certain amount of distance to be able to get up to full speed. So again, very, very important. And these machines are very, very quick for small movements, small runs. You know, do have a lot of people that do rotary engraving of mugs and everything like that. And if you don't have those very high energy motors, the engraving can take a heck of a lot longer, because a lot of times it's a very short movement area here. Okay,
and that's why we when we talked about production or making 1 versus 16 coasters, we tend to say put them along like the x-axis, right? So you get the full speed across the full engraving.
Exactly. Okay, so I have my settings here for basically most machines. You have a printing DPI here. I could put enhanced geometries on, and basically what the machine is doing is it's processing the Bezier lines as Beziers, not as a circle, which would sort of be a small series of it does. If you really zoomed in on it, the machine movement is more of a straight line as opposed to a smooth movement. So again, your quality of your cut's going to be is better with the enhanced geometries. Inner geometries basically just means that it's processing inside out. A lot of the machines that we're selling now have have the new electronics in there, and the new electronics have such good look ahead capabilities that they can actually go out now and they can actually assess objects on the bed, and they can actually move to a certain object if the software feels that it's a shorter movement. So again, if it's a closer object, it'll go to that one instead.
Right, and I mean, you want to do inner geometries if, like, let's say you're cutting the capital letter A. You don't want the machine to cut around first, because then it could slightly drop, and then it'll cut the inside of the A afterwards. So you want to cut the inside first.
That's the inner geometries.
Yeah, that's what I'm saying. The inner geometries.
Yeah. Quick print allows us to send the job over to the laser, and it just starts engraving. I'm not going to do that. I'm just going to send the job over. I have a print preview here typically, so I can see the job. Remember, the job's only going to be the size of the object, not the size of the page. And that's typically for these sort of demos. That's what I'm doing. I already have the job on the bed here. You'll notice that the software gives us an estimation of time before it works. And this crosshair here is the red dot pointer that's on the bed here. So again, I can move that wherever I want on the bed. And you can see that laser head move on the screen, and then I can take the artwork and I can snap it however I want it, whether I want it here, there, on there. In the software, I can actually take that and I can duplicate it if I want. Again, and that starts to give me a lot more speed in terms, because now the machine is moving totally left to right, so I get a lot better speed on there. So I can just take that, snap that over there.
And so this is going to be basically at the bottom right of your laser head.
Well, that's right in the middle right now.
It's in the middle. Okay, gotcha.
I put it in the middle. But yeah, again, if bottom right would be there, bottom.
And it just snaps on. Okay.
It just snaps right to there. If you zoom in on it, now you can actually move it wherever you want. You have a XY coordinate here. So, if I want to move it a little, if I want to go to 15.5, I can take that job there and then move it over to 15.5 if I want. And, again, if I want to move it around, I can.
It can be very precise, basically.
Yep. So all I need to do now is basically just hit the run button.
So while we have this engraving, we have tons and tons of questions, Mike, which is all great, guys. We're gonna try to get through them all. Okay. Let me just get Mike here. 1 second.
I'm just gonna go unlock the door.
Yeah, no problem. Oh, let me zoom in. So Mike, you can still hear me, right?
Yep.
Okay, so we have one question from the United Nations Council of Indigenous People are asking, can these lasers do angular perimeter cutting? I'm not sure what they mean. I don't know if you do.
They might be looking for a chamfer type, where you cut on an angle, as opposed to like the laser beam cuts 90 degrees straight down. So I think they might be asking about more of a bevel type scenario. You can turn your product on an angle, cut on an angle, but for the most part, if I think I know what you're asking, I would say no.
Okay.
Okay.
Next question. Oh, this is a good one. Can you adjust the PSI of the air assist for working with different materials like acrylic or wood?
Yeah, you can. On the 360, which is really cool, is you can actually adjust the airflow on the laser arm itself.
Don, can you zoom out? Is Mike showing us something?
No, I'm sorry.
Oh, I'm sorry.
I am, but it's the machine's running.
Okay.
Yeah, sorry. But yeah, there's an actual flow control on the arm, the same as the 400. So on the 300, you'd have to take the side panel off, and then the pump has an adjustment on it. So again, you can do it on all the air assist pumps that are supplied with the machines, either on the pump itself or on a regulator that's actually mounted on the arm.
Perfect. We have a LinkedIn user asking, I started to use Affinity Designer. It's a vector program. Will be nice to know if it was compatible. There are any file formats specific to use?
Well, if you're using job control, as long as the Affinity program is outputting vectors, then it can cut. Most every program is going to allow you to engrave. The question for most people is, am I getting that output from the design program that's vector so I can cut? And is that output line width proper so that the machine will recognize that I want to cut that line? Now in Ruby, that's a little bit easier now, because we can actually now import directly right into. So we can actually output directly right into Ruby. And therefore we don't have those issues anymore. But again, as long as Affinity is outputting vector lines, then we're good to go. So
perfect. Raheem's also asking, what about rastering on acrylic? Should we also use the bigger nozzle?
Well, the bigger nozzle typically is going to be on there because we normally want to cut. If I'm just engraving acrylic, then I don't put the nozzle on at all. Okay, and the trick to engraving acrylic is very, very minimal power. I don't go into the acrylic at all. If you watch any videos that I've done on acrylic, that photograph I did, on the acrylic.
I'm just going to pull it up right now. Yeah.
That one, again, very minimal power. I'm on an 80 watt at full speed. I'm still not using 100% power. Right, because the problem a lot of times is that, yeah, so you can see there that that detail is dictated for two reasons. One is that I'm not going deep into the acrylic, and the spot size is very, very small for that reason. So but yeah, I don't put a nose cone on there, and if you want, you can just pass the air through it to keep the optics clean. So.
And I mean, if you're engraving like a full sheet of acrylic, let's say it's the entire bed size. Sorry, if it's the entire bed size, I mean, you're gonna, especially if you're using a lot of power, I mean, you're gonna have that dust clog up the nose cone, right? At one point, you got to pause it and take some of that dust out.
Yeah.
Oh, sorry, Don. 1 sec. Let me just zoom in on that. There we go. Does that pop out? Do we put enough power?
We use enough power on there? I thought we did. Yep.
Oh, there we go.
Don's not strong enough. I had to push it out. So. The marketing guys, their arms are like this,
Oh, wait, we can't see what you're doing, Mike. Arms like what? Okay, we're at the hour mark. We're probably going to go another 10 minutes, 10, 15 minutes over, because we have some really good questions.
Be careful, because I have somebody coming in, so if they come in, I'll have to leave.
So. Okay, not a problem. So let's try to get as many as we can. Environmental exhaust hazards for various materials. But can you tell us a little bit about that?
That's really going to depend. What you want is an MSDS sheet.
Right.
the materials safety data sheet. And again, you're going to get that from any products that we sell. That sheet is available for you to take a look at, so you understand what's being removed when you're actually cutting the material. Very, very important that, especially if you have, schools or companies, where their employees or their students or whatever using the equipment, and they are around the machine, that you understand, what's being pushed in the air. The problem, the one thing that I always tell people when they're using the machine is always let the exhaust run for a little bit longer, but when the job's done, before you open up the lid. The other problem that I have personally is every time I lift the lid up, I inhale. I don't know why, but I do. So again, very, very critical that we get all the smoke out of the machine before the lid is opened up. So that if somebody does open it up, then they're not being exposed to anything that's not good. And people are a lot of people are different, and some people react differently to certain chemicals than other people do. So again, very, very important, if you're using this machine in a more public environment, you're a makerspace or whatever, that you understand what people are etching. And very, very important that you understand it, because you don't want liability, right? Especially if you've got people bringing stuff into your area to use on the machine. You always want to make sure that you know what they're doing, okay? Because some materials, they're going to give off cyanide gas. They could give off chlorine gas, fluoride.
Well, let's be more specific. I mean, PVC-based materials are a big no-no for Trotek. The materials that we sell at Trotek, they are laser safe, but like Mike said, check MSDS sheets. The problem is if you're buying from AliExpress, some acrylic from some factory in China, you might not always have those kind of MSDS sheets. So just be cognizant of that. And like Mike said, especially if it's a makerspace, people are bringing in materials, you don't know what it is, ask them to make sure they have MSDS sheets. How often would you need to clean or change the filters on that? Can you vent indoors when using acrylic?
Yes, you can. The biggest issue is that I can't tell you how long they're going to last, because that's going to be dictated by the material you're engraving. Acrylic tends to generate a lot of dust. The dust isn't that sticky. It's not like MDF dust where you've got plastic, where you've got the glue in it, but it will fill up the bag relatively quickly. So again, it really depends. If you're cutting 3 millimeter all day, it's certainly not going to fill up as much as if you're cutting 6 millimeter all day, right?
And the more dustier materials like rubber and MDF, right? Like if you're doing rubber stamps, that would be the most.
Yeah, and certainly MDF, the glue on MDF tends to contaminate the bags very quickly. So a lot of times, we'll take the bags out, we'll put them aside, put new ones in, let the film inside the bag dry, and then you can kind of shake it, and then get the stuff out, and you can reuse the bag. But yeah, typically once that bag is coated acrylic or standard wood or lamecoid, the bag goes in the garbage. So
yeah, and I mean, speaking of rubber, I mean the machines, the Trotek machines, they were born from stamp making, from Trotek, our sister company. So these are production machines. They're made to withhold and withstand rubber engraving, which is probably the hardest engraving to do. And Mike, if you could show
if you look at the machine here, what we've done on the machine is that we've enclosed the optics. So again, if you have to clean a lens, the lens just comes out. I can easily clean it. I can put it back in again very quickly. And the problem with if we don't make it easy, then it's sort of an out of sight, out of mind scenario, and then you end up blowing a lens very quickly. So you need to be cleaning your lens on a regular basis. Could be 2-3 times a day, depending on what you're doing. So again, we need it to make sure that people can get at that lens quickly and take it out. This is a steering mirror, again, that can be removed quickly. You'll notice the metal reinforced Kevlar belt here. That's pushed tightly against the frame of the arm to mitigate the dust getting back on the linear rail that this head is traveling on, and the bearing on here is sealed. So again, there's no lubrication or anything that has to be done on the physical arm itself, because you don't want to use grease or anything on a machine, because any grease on there is going to attract dust, and then over time that's going to cause issues. You'll also notice that we have the harsh environment kit straps on here, and that keeps again the dust away from any electronics or the lead screws for the physical table itself. Also on the machine, the one reason I like this machine for doing a lot of cutting is we also have a downdraft table. So we actually, if I open this up, you have a port here that's drawing smoke this way and debris that way, and it's also drawing debris to the back. Okay, so again, very, very important when we're doing a lot of cutting that we remove the material as quickly as we can. And having a downdraft table like this is very, very important. And that's why the 360 and the 400, similar construction. So if we have people that are doing a lot of cutting, then, you know, certainly the 360 and the 400 have advantages to them, especially if that material is 3/8 or 1/2 inch.
We're almost out of time, but I think we can put in a few more questions in. This is actually a great one. What is the big difference between the Speedy 300 versus the 360? What may lead someone to choose the 360 over the 300 or even the 100?
Well, the 300 and the 360 are pretty similar in terms of, like, they use the same arm, they use the same motors, so the speeds are the same. The engraving quality is the same. The big difference, as I mentioned, is the downdraft table on the physical machine. The grid table, you'll notice here on here, the tables are, you have a grid table on here. You can get a slat table, you can get a ferromagnetic table, so that you have a little bit more choice in terms of tables. On the 300, you have the vacuum table and you have a honeycomb table. So you really only just really have a solid table and a cutting table. That cutting table has to be taken out if you want to go to the ferro table, because you don't want to cut on the honeycomb because it's not as strong. Where the grid table on the 360 is very, very strong. So a lot of people will use this table even when they're raster engraving. So again, that's one reason. The one nice thing on the 360 is that they have the adjustment for the air on the arm here. On the 300, I'd have to open up the side panel to get in there to adjust that. The 10 inches of lift on the 360 versus 8 inches on the 300, so a little less lift that way. This is 31 inches wide. I can go through a 32-inch door. I can go through a smaller door with a 300. I just need to turn it on its side because the machine is not shipped with the stand, so easy for me to get through a door. The laser source is mounted on the back side of the 300, where the laser source is mounted on the bottom. So an extra mirror on the 360 versus the 300. That's a little bit better. The nice thing about both machines now, because the electronics have been upgraded on the 300, is that the 300 and the 360 are key switched. So very, very important for student, schools and everything like that. This machine has an e-stop on it. You can get an e-stop on the 360 if you want, but the key switch is normally very, very important. 360 is a little bit wider, 3 inches wider than the 300, and 3 inches deeper on the Y. So a little bit bigger that way. So, certainly some reasons why you would want to go 360 versus 300. For me, most of that is cutting. If you're looking to stack as much product on here, the 360 is a little bit better because it does have the extra 3 inches. But again, it really depends on your application. So.
This is a good question here. Does the 360 have any sort of camera on the bed for orienting your materials? So you want to lay out several pieces at a time? I mean, we can talk about the vision camera system that we have.
Well, the vision camera is for picking the registration marks up. I think what Dave's asking for is positioning of seeing the actual image on the screen.
And we don't have that at this time for
well, no, but we do have the job control software. And again,
right.
That's very, very important, where you can actually see the laser head on the screen. Because typically what people are looking for, we can outline the job on the screen. We have a command in job control that outlines it. And basically, I always tell people, I never have any problems being able to locate things on the screen, and especially with the job control, where I can see the camera on the screen. So if I'm moving the head around, I can put that red dot pointer right over the material. And then if I want, I can snap right in here. And if I zoom in on this, and then I can move the head to make sure that it fits on the bed or on the product. So again, I can move that around and I can see that exactly like that. So again, I do that most of the time. I'm not even that is not even a consideration, because most people are doing multiples. They're doing large pieces. They're doing 30 ornaments at a time or whatever. So they're laying out a big sheet, and so having that really isn't really a big deal for most applications. So.
Okay, I think last question. I know we have more. Guys, thank you so much for all the questions. You can always email us at youtube@troteklaser.ca, and we'll try to answer them as well. I just saw one. Oh, here's a good one. What are the advantages of purchasing a Trotek over a significantly cheaper 100-watt Reci or Reci laser and Ruida controller-based system? I'm guessing it's a Chinese machine. I've never heard of that specific laser. But Mike, if you could, as a last kind of comment, what's the difference between the Troteks, who are more expensive than the Chinese machines? Why would somebody want to buy a Trotek?
Well, the problem with a 100-watt Reci tube, and we do sell a Reci system in the R500, is production speed, and the 100, it's a glass tube. That's the difference is, I mean, if you want to learn about the RF controlled tube, then you can go see the video that Trotek's done on the Radeon tube. But the problem with the Reci tube is a glass tube. I know is life. And normally the lifespan is maybe 800 hours. Where you're looking at substantially longer life on a laser source. So again, you're having to change that tube on a more regular basis. So again, this is an argument against, say, a Glowforge, which is a glass tube, which is your basically your Reci tube. If your glass tube goes down on a Glowforge, you've got to send that machine back to the US. Mm-hmm. Okay. Now, if you buy a Chinese, say, type system or something from the US, because there are people that are buying the components from offshore and they're building their own systems, somebody has to send a tube up to you and you have to put it in yourself. Right. So again, there's a service issue, and that's really one of the big disadvantages. From a production standpoint, a glass tube normally is only going 40 inches a second with a stepper motor system. So the speeds are greatly reduced on a glass system. A lot of those systems sometimes aren't using a beam expander, so the quality of the engraving is not very good. The quality of the beam geometry is not very good. So there's issues with cutting quality. So again, there's I've had a number of people that come in here that have these types of systems, and they turn to me and say, either I buy your system or I get a business, because they can't produce product fast enough. And
that's my main comment. We do produce, like I was just showing the R500 video, we do produce glass tube lasers as well, that are might be good for simple sign making operations. But like Mike said, it's the difference is the production. The production machine is there for longevity, for quality, and just basically for if you're running a business, you want to have the laser that's there to produce products to keep you in business. So
yeah, because what I tell people is the machine doesn't break down, like it doesn't come down in the morning and say, I'm going to break down in a week. Okay. What's going to happen is you're going to be running a job and it's going to break down, and now you need support, right? Now, what are you going to do? Are you going to send your machine back to the US? Probably not. So what ended up happening with some people is they get a refurb, they send that to them, and then it takes 2 weeks to get here. Then they got to send their old machine back, right? So, in the meantime, what are they doing with all the jobs, right? Is the machine they're getting, is it better or less than the one that they got? So again, service is really is the big issue. Quality, speed. I always tell people, I mean, you can go to Canadian Tire, you can go to a hardware store and buy a cheap drill, right? Because you might be going to drill a couple of here and a couple of here, and if it breaks down, who cares, right? But if you're charging somebody, if you're a handyman, you're going in and you're working on somebody, and you're working, you based a job based on an hourly rate. You can't afford to be sitting there because your drill broke down or your saw broke down or whatever. You need something that's reliable. So people pay a lot more money for that reliability, so that they don't want to worry about it, right? Because if you lease the machine and it costs you $500 a month, and you break that down into a cost per minute, it's such a minimal amount of cost. It's a minimal amount based on everything else that's going into your business, right? And you don't want to tie everything up hanging on this cheap machine that might or might not work next week. And that's the way people look at it.
Okay, we got to wrap it up. Sorry we couldn't get to all the questions. Somebody was asking about videos. I put the link on there as well for all our videos on our YouTube channel. Thank you, everyone, for this live stream, especially Mike, the guru. Thank you for all the knowledge you're dropping. See you guys next week on another live stream. Thanks again.
Thanks.
Bye, guys.